This is part one of my presentation for the final exam. I'll get started with question number one. A student draws the graph of a function f of x as shown to this parabola right here. He claims that the average rate of change of the function over 0 to, right there, is -2. Is he correct? And explain. The short answer is no, he is not correct. That's because the equation for this parabola is y equals x minus 2 squared. Ignore this plus z, because I'm use that to explain a problem later on, but we don't need that for this question. So I know that this is the equation for this parabola because this -2 right here. This term right here tells you what the x-coordinate is. And that, since it's -2, it goes to +2 on the x-coordinate. If this was a +2, it would land on the -2 on the x axis. But to find the rate of change, we have to look at the number before the x, right in front of the x. In which case, it's blank, which means that it's an invisible 1. And that invisible 1 is not -2. So that is why he is incorrect in his claim that the rate of change is -2. Question 2, it says identify each equation that has exactly 2 distinct imaginary roots. To this, we have to use the quadratic formula, which says x equals -b plus minus the square root of b squared minus 4 times a times c over 2a. I didn't have enough space, so it's really sloppy right there, but that is the formula. Now we need to plug in the terms in this equation into that formula. There is no b term, so the b just equals 0, and that means the equation says x equals -0 plus minus square root of 0 squared minus 4 times 1 times -2 over 2 times 1. And once we simplify this part of the equation right here, we get +8. 0 times 0 equals 0. And then 4 times 1 times -2 equals -8. And 0 minus -8 equals +8. And since this number under the square root is a positive, that means it does not have imaginary roots. So this is not one of our correct answers. But if we look at x squared plus 4 equals 0 and plug that in for the quadratic formula, that again does not have a b value, so all b values equal 0. 0 minus 4 times 1 times 4 equals 16. Then 0 minus that 16 equals -16. And that means we have x equals plus minus square root of -16 over 2. But since this number right here, this -16, is under the square root, that means that it has imaginary roots. If the number right here under the square root is imaginary, is negative, it has imaginary roots. So that's why x squared plus 4 is one of our correct answers. And for 4x squared plus 2, it also doesn't have a b value, so it just equals 0. -0 plus minus square root of 0 squared minus 4 times 2 over 2 times 4 equals x equals plus minus square root of -32, because 0 minus 4 times 2 equals -32 over 8. And again, this is negative, so it has 2 distinct imaginary roots. So 4x squared plus 2 is one of our answers. Now for x squared minus 3x plus 2 equals 0, which I show right here. The quadratic formula is x equals 3 plus minus square root of -3 squared minus 4 times 1 times 2 over 2 times 1. And once we square -3, we get 9. Then simplify this part, right, these 3 right here, we get 8. Then all of that is over 2. And then 9 minus 8 obviously equals 1. And that 1 is positive, so there are no imaginary roots. That is why this one is not one of our answer choices. For 2x squared minus x plus 5 equals 0, we have x equals 1 plus minus square root of negative 1 squared minus 4 times 2 times 5 over 2 times 2. Then, once we do all this simplifying, we get x equals 1 plus minus the square root of 1 minus 40. Then 1 minus 40 obviously equals negative 39. That means this also has two distinct imaginary roots. And then for x squared minus 4x plus 8, it's the same deal. Plug in all numbers where they're supposed to go. Simplify the terms right here. And that leaves us with negative 16. This one also has two distinct imaginary roots.